Okay, so I'm going to do an example on the board here, and then I'm going to let Brandon do one on the paper so that it will actually be more consistent with what you guys are doing at home. So instead of doing the 4.9, I'm going to do the differential arrival time of 2.5 minutes. That means that the P wave and S wave arrived at different times, which we know they would, and that the S wave arrived 2.5 minutes after the P wave arrived. So if I say that from here, which is 0, to here is 2.5 minutes, and if I want to find where the difference between these two arrivals times equals 2.5 minutes, what I'm going to do is take a scratch sheet of paper, in this case cardboard since it's so long, it's on the board, and I'm going to make a little mark at 0 and a little mark at 2.5. That way I have the distance that means 2.5 minutes. Then I'm going to keep my paper, my scratch paper, vertical and slide it up in between these curves until I find the exact match, which is going to be right about here. So here is the distance that equals 2.5 minutes differential arrival time, and we see that there's exactly that space in between these two curves. So now that I've got that drawn in, I'm going to extend it down to the base of the graph and find that 1.3 kilometers to the third power is the distance that 2.5 minutes of arrival time difference equates to. So now we're going to do it for real, and we're going to look at this same example, 2.5 minutes, in the next video to try and see if you guys are doing it correct at home. So in between this video and the next, go ahead and try it yourself, and we're going to explain it in just a second.